Okay, we are going to start handout 5, and we are going to classify real numbers, which is classifying all types of numbers. So we've already talked about rational and irrational, and now we're going to break down rational even further. So if we kind of relate this graphic organizer to real life, when you read this, it talks about Ethan having going to like a camp, and he's met lots of friends there. And so the graphic organizer, we're supposed to place the letter of each category where you think it belongs. So the middle one should be the most specific. So the most specific would be that they are in the same class. So B would be here. And then heading out from there would be the same school. So obviously, if they're in the same class, they're already in the same school. And if they're in the same school, then we know they're in the same city. And if they're in the same city, then we know they're in the same state. And then we know they're friends from camp. But they might start out where they're not in the same class, but then they're at the same school, and then obviously the same city and state. Or some friends he met at camp might just be in the same city, therefore in the same state. Or he might have just met some friends from his same state. And then he would have met some friends from out of state. So this kind of represents our irrational numbers over here. And then these are all of our rational numbers. And then all the different types of numbers fall in there. So what's the best section to place Ryan's name? Since it says they go to the same school and the same class, B would be like the most specific section. And then it says, where would Ryan belong on this? He could be in all the categories except E. Okay, so we can also use that for real numbers. And like I said, real numbers just are all the numbers. And they want you to give 3 examples. So first we have natural numbers. This is the set of all positive counting numbers. So like the numbers, when you look up at my number line on the positive side, and they start with the number 1. And counting, like this is how you would teach a kid to count. So you have 42. You could have 8,000. You could also have it as a fraction, as long as when you divide it, so like this, as long as when you divide it, it's still a positive counting number. Okay, so that natural, after that, would be whole. So if it's natural, it's automatically whole. And so whole is basically everything we just said, except they start with 0. So it's everything just adding 0. So we have 0, of course. And then we have just any number. We could even have a square root, because if we'd have like the square root of 100, that answers 10, and that would be a whole number. Okay, integers. So moving up, like in this thing, we would have natural and then whole, and then both of those would also belong as an integer, because integers are the set of whole numbers and their opposites. So it's all positive and negative whole numbers. So you could have the number 25, or you could have the number -5. You could have the square root of 81, or you could have the opposite of the square root of 81. You could have a fraction, 15/3. Any of those would work. And then if they're an integer, then they're automatically rational. So rational is numbers that can be written as a fraction. So for example, this one, 15/3, when you figure it out, that's 5, but it can be written as a fraction. -5 can be written as a fraction. You just put a 1 under it. They're also terminating decimals, which means they stop or repeat. So you might have a 1.2 or you might have a 2.4 repeating. And they're also all the perfect squares. And so by now you should know what that means. So any square root that when you do it, it comes out as a whole number. So 121. Okay, so all of those would fit here. And then the other thing would be irrational. And then all of them would be real numbers. So irrational is kind of just the opposite of that. They're numbers that cannot be written as fractions because they do not terminate and they do not repeat and they are non-perfect squares. So the square root of 80. We already know that that number goes on forever. We can estimate it and make it smaller, but it goes on forever. So you can't put that into a fraction because it never stops. Pi is the most common one that you kind of think of. Sometimes they'll put a decimal point and then they'll like go dot, 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 as long as it's not like a repeating pattern. Okay, so we're going to place the headings in here now. So inside we have natural, and then we have whole, and then we have integers, and then we have rational, and then we have irrational over here. And they are all considered real numbers. So let's start with, and we're going to place it like in the most specific spot, not all of them. So for example, 0, we know it's not natural, but we do know it's a whole. And so we also know it's an integer and a rational. I guess we'll do them all. So as soon as you find the spot that it starts in, it's always all the rest on the rational side. Okay, square root of 75. That's not a perfect square. So that's going to go over here. Okay, I've got those done. 16 over 4. Well, I know that equals 4. I know a 4 is a natural counting number. Therefore, it's whole, it's an integer, and it's rational. -15. Well, that's not natural, nor is it whole. So it is an integer, and it's rational. Okay, 2 square root of 64. Well, we know that that is 8 times 2, which is 16. So that is natural, whole, integer, and rational. And the last one, -12.2. So I know it's not a natural counting number, so it's not whole. Is it an integer? Some people would say they think it is because of the negative sign, and that is not true. It is rational because it is a decimal number that stops. Okay, so for each of these below, let's list all the number sets to which they belong. And then circle the most specific one, which would mean like the most, the one that would be in the center. So I'm going to have you go ahead and stop and pause and then check back with your answers. Okay, go ahead and look at your answers. You see pi, you know it's irrational. This is not a perfect square. The third one is it equals 9, so it's all of them. This one, it's -8, so it starts at integer. And then the last one is a decimal that stops, so it's rational. Okay, so give an example, and our numbers are going to be different. An irrational number with a value greater than 10. So it needs to be a non-perfect square if you're going to do a square root. And it has to be greater than the square root of 100, because that's 10. So you could do square root of 101. Anything bigger than that. Okay, a whole number less than 0. Not possible. Because whole numbers start at 0. A rational number represented as a square root. So this one, if it's going to be rational and it's going to be in the square root form, then it has to be a perfect square. So it has to be, any perfect square. Because if it's not, then it's not rational. And you can probably hear my dog again. Okay, an integer between -5 and -6. So again, that's not possible because integers are whole numbers. And so you cannot do that. Not possible again. Okay, so I would recommend doing the homework on this, or at least doing it sometime in the next few days.